So that's the laundry list of questions that I got, which is fine. I'm just going to start with the 25 first and work my way up, so it'll be a second before I get to those harder ones. But number 25 was just a straight up factoring problem. So you could guess and check, or you could split the middle term. Because there's not a lot of choices on 3x squared, I think I might do 3x and x. And then I would have to check 1 and 28, 2 and 14, and 4 and 7. So 1 and 28 is going to give me way too big of a number on the outside. 28 here and 1 here, coincidentally, is going to be it. Because on the inside I have 28x. On the outside, it's going to be a 3x product. And I want it to be a negative 25, so I'm going to make the negative 28x and the positive 1. So 3x minus 28x plus 1 will work. We've got 3x squared on our first, negative 28 on our last. Outer is 3x, inner is negative 28x, and 3 and negative 28 combined to negative 25. So that's number 25. 61 was just a difference of perfect cubes, I got asked. So that's just following the structure. It always goes into a binomial, trinomial. We take the cubed root of this, which is 2x, because 2x times 2x times 2x, and the cubed root of 1, which is just 1. And then your signs are same, opposite, always positive. And to get the 3 terms of your trinomial, I only look here. Square this, 2x times 2x, gives you the first term. Square the 1, it'll give you the last term, and then multiply them together, 2x times 1, and it gives you the middle term. On 85, we're getting closer to the good stuff. 85 is x squared minus 12x, 4 terms, but 2 by 2 grouping doesn't work. This is very similar to the one we did in class, where it's a 3 by 1 grouping. This trinomial is x minus 6 times x minus 6. In other words, x minus 6 squared. And once you see that and get that, now you have the difference of a perfect square and a perfect square. Difference of perfect squares factors into conjugates. So we have x minus 6 plus 7y and x minus 6 minus 7y. The square root of this plus the square root of that, the square root of this minus the square root of that. Jenna. Okay, and I think I mentioned that, so if I group the first two and I take out an x and I have x minus 12, plus, if I then group this and factor it into 6 plus 7y and 6 minus 7y, that's not factored means come up with what times what gives me that expression. This is, there with that plus sign in between, it totally throws the whole thing. If you're ever wondering if that's possible and maybe you didn't put the plus sign so it looks like factors to you, all good. Distribute the x and distribute that through and start distributing it all, and it's going to be very far away from that, and that's how you'll know it's not okay. All right. 91 was 2x cubed, kind of a longer one. And the very first thing I notice on this one is that there is a GCF. So you should get that out of there right away. 2x, 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 2x can come out of all of them. So starting there, minus 4a squared plus 12x plus 36. And now with what we have left here, if you grouped it 2 by 2, again you have the difference of perfect squares, but then just pulling out a 12. So you can't, that would be like trying this, which didn't work above. But if we rearrange this with the x squared plus the 12x plus the 36, you can just rearrange your terms so that you do have that, obviously the 2x is still in front, you do have that trinomial here. So again, the 3 by 1 grouping, this is going to be x plus 6 times itself minus 4a squared. And then with this section again, difference of perfect squares again. X plus 6 plus 2a and x plus 6 minus 2a, with, of course, your GCF out in front. So that was definitely a tricky one. Okie doke. And now we get into the fun stuff with the rational exponents that it didn't look like everybody didn't get any of them, but it was sporadic. Like a couple people just missed one of these, which by the end of me taking a tally of all the questions, everything got asked in this section at least one time. So we're taking out the base with the smallest exponent, which is the 1/2. So x to the 1/2 is going to get divided out in front, and you have to figure out what's left of each piece. So if I divide out the x to the 1/2, when I divide common bases, I have to subtract the exponents, and 3/2 minus 1/2 is 2/2, and 2/2 is just 1. And if the exponent is just 1, I don't need to write it. And then I divide x to the 1/2 out of here, anything divided by itself, and there's your final answer for 95. That was very similar, if not the same, as the first one we did in class yesterday. 97, okay, bumps it up a notch, because your base is more than just an x, so that creates a complication. And we have no, not bad. So which one of these is a smaller exponent? Easy question, right? 1/2, okay? So I need to take out that base of x plus 3 to the 1/2 power. And then I'm going to see what's left of each piece when I divide out that, because you're like undistributing, right? So when I divide out x plus 3 to the 1/2, the first term is just 1, anything divided by itself, minus when I divide out x plus 3 to the 1/2 here, I keep the same base, which is a binomial, so especially with that negative sign in front, keep it locked up in parentheses. And then 3/2 minus 1/2 is 2/2 is 1. So an exponent of 1 technically on there. And then we just need to clean up what's in the parentheses by distributing our minus sign. 1 minus x minus 3 is going to make it negative x minus 2. And somebody asked, would that be an okay final answer? Of course, right? But what you will notice a lot of times just professionally in math, having a trinomial, binomial, any polynomial start with a negative, for some reason people don't like that. I don't know. I don't like it either, but maybe that's just because I never see it that way because they always take it out. So you may see the negative being taken out in front, and this would turn to an x plus 2. So just a word about the answers in the back of the book on that one. So far, so good? Any questions? Okay, 99 was x plus 5 to the negative 1/2 power minus x plus 5 to the negative 3/2 power. Which one of those exponents is smaller? Negative 3/2. So I'm going to take out x plus 5 to the negative 3/2 power, and then I'm going to see what's left of each piece. And so I'm dividing just so I can see it, because this is not as easy of a division as most taking out the GCFs is. So on this one, dividing common bases, you keep the same base, and then I have to subtract those exponents. So I'm going to do this on the side. Negative 1/2 minus negative 3/2 is negative 1/2 plus 3/2 is 2/2, which is 1 again. That's not a coincidence. That tends to happen. You guys have noticed probably over and over again that it ends up being 1. I wouldn't just jump there. I would make sure you understand it, because gosh forbid there's a time when it doesn't end up that way and you just jump the gun and put a 1 there to make your life easier, and then you get burned because of it. So, but just know that that is obviously not uncommon. And then here we're dividing it by itself. So anything divided by itself is 1. We're going to clean this up twofold. Number 1, in here we're going to combine like terms, so it's going to be x plus 4. And number 2, this with a negative exponent is going to move to the denominator. So x plus 5 to the positive 3 halves. Okie doke. And 101. And 4x minus 1 was our base. Minus 1/3. So they threw a little twist at you, throwing that 1/3 in there to the 3 halves. That doesn't change the fact that they have a GCF of 4x minus 1 to which power? 1/2 is the smaller. So I'm going to take out a 4x minus 1 to the 1/2 power. And then I'm going to see what's left of each piece. So when I take out the 4x minus 1 to the 1/2 power here, anything divided by itself is 1. On this one, when I take out the 4x minus 1 to the 1/2 power, the 1/3 is still there. It's minus 1/3. And then my base, always when you're dividing common bases, keep the same base, subtract the exponents, 3 halves minus 1/2, 2 halves, 1. And then when I distribute here, I get 1 minus 4/3 x plus 1/3. And then 4x minus 1 to the 1/2. Now, question for you. Did they not like the fractions in there and maybe they took a 1/3 out in front? Okay, so now this part is just kind of being able to make the connection between, that would be okay if it's open response. But if it is multiple choice, you do want to know what to select. So by taking out a 1/3, and I'll put it in front of this fraction for the moment, just for the ease of thinking it through. If you're dividing out a 1/3, what would this now become? Or think about it this way, 1/3 times what would give you 1? 1/3 times what would give you 1? 3, exactly. And on these, when you take out the 1/3, it just becomes minus 4x, take out the 1/3 plus 1. That actually gives us the ability to clean that up even further. 3 plus 1 is 4. So negative 4x plus 4. Now I'm going to write the 1/3 way out in front. And then I have another question, because I didn't check the answers in the back of the book. Did they bring that negative out in front also? Did I screw something up? What? So they put the whole thing over 3 probably. You can either have a 1/3 coefficient or you can put, did they bring the negative out in front? Okay, because if they're doing that, so negative 1/3, 4x minus 1 to the 1/2, 4x minus 4. Oh, we can take a 4 out, right? Now we can take a 4 out. I could have realized it there, but I didn't realize it till there. So now in my book, it's negative 4/3 because I'm taking a 4 out in front. So negative 4/3, 4x minus 1 to the 1/2, x minus 1. And so another way of writing this same thing is with the negative 4 on the top. And I think this is what you're telling me. All over 3. Okay, so, I mean, that takes some seeing to realize, okay, what actually went on here. That makes it clear to me why 101 was asked a lot of times. Good? And sometimes, yeah, you'll have to do a little work to kind of manipulate it and at least understand where the back of the book is coming from. 109 and 111. 109 are our last two. X to the 4th minus 5x squared y squared plus 4y to the 4th. Trinomial, a little more complex because you've got x's and y's. But if you find two numbers that multiply to get 4 and add to get negative 5, they are negative 4, negative 1. So I'm going to use that to split up the x squared y squared terms. X to the 4th minus 4x squared y squared minus 1x squared y squared plus 4y to the 4th. Whatever that middle term's concoction of letters is after the fact, that stays on each one of those. Your uncombining like terms, you group, pull out an x squared. You group here, pull out a negative y squared, it looks like. And those are matching, so we're good there. But I'm noticing that each one of these is still the difference of perfect squares. So this will be x plus 2y and x minus 2y. And this will be x plus y and x minus y. And 111. Was this. So I'm seeing this as two terms. They both have an x minus y, and the smaller of the two exponents is the squared. So I'm going to take out an x minus y squared. What I'm left with is still two of these x minus y, so x minus y squared, and then minus 4. This second piece, though, is the difference of a perfect square and a perfect square. So this part is going to factor into conjugates. X minus y plus 2 and x minus y minus 2, and then of course your GCF out in front.